Welcome! This is an example of using the disk method to find the volume of a solid. The disk method is used when we're drawing rectangles that are perpendicular to the axis of rotation. A lot of the times you could use the disk or the shell method. So as you visualize drawing in the rectangle that's going to revolve, look at if it's perpendicular to your axis or parallel to the axis. If it's perpendicular to the part you're rotating around, you're going to use the disk method. When you visualize this rotating, you're going to find a thin cylinder. We're going to then find the volume of that cylinder. And if you think back to geometry, the volume of a cylinder is pi times radius squared times height. And the actual equation is what's going to give you your radius. Then what we're going to do is integrate that. We're summing up lots and lots of little cylinders. And the limits of integration are going to be the intersections of where we start and where we end. So basically the region we're rotating around. We're going to do an example together. Let's find the volume of a solid that's going to be obtained when we rotate y equals x squared minus 4x plus 5. And we're going to do that in the region contained between x equals 1 and x equals 4. And you'll notice in this case, we're not going to be starting at the origin. In some of our other examples, we always had 0, 0 as a point, and so your end integration simplified down a bit. But here, rotating that bound region gives us a starting of x equals 1 and the end of x equals 4. First, let's look at why this is a disk method. You'll notice in the top left that I drew a little blue rectangle. When I take that rectangle, or the whole region, and rotate it around the x-axis, I'm going to have the shape that's over on the right. If I were to slice that shape in the same vertical direction, what I'm going to end up with are lots of little cylinders. So you'll notice in the bottom right, I drew a cylinder. The width of that cylinder is the width of my rectangle. And the width of the rectangle is just dx. It's basically the change in x. So whatever interval I'm doing, that region or that width is my dx. The radius is just determined by that point on the graph. So the radius, the height of that blue rectangle, is going to be whatever that y value is. So my y value is x squared minus 4x minus 5. That was the original equation of that parabola. Now when we're trying to find the volume of a cylinder, as I said before, is pi times radius squared times height. So here you have to do a little bit of algebra. So in other words, we're going to take pi times the radius, which is that parabola equation, x squared minus 4x minus 5, the whole quantity squared, times dx, which is the height of the cylinder, because the height or the cylinder is laying here on its side. So use your FOIL method to expand x squared minus 4x minus 5. That would be an algebra review. So expanding out the radius gives us x to the 4th minus 8x cubed plus 6x squared plus 40x plus 25. You may want to pause the video and make sure that when you expand your radius, you can get the same answer. Now that's the volume of one cylinder. Again, we have lots of cylinders that we're going to add together to find that whole solid. So to add all those cylinders together, that's integrating. It's summing them up. So I'm going to sum that volume formula, pi times the radius squared equation, which I've already expanded, dx, and I'm going to do that from 1 to 4. I picked those limits for my integration because those are my x values. That's the region that's bound between 1 and 4. Now it's an integration problem. Remember, when you integrate, what you're doing is you're raising your exponent by 1 and then dividing by that new exponent. So I take the x to the 4th and raise that by 1, so that becomes x to the 5th, divide by my new exponent, minus 8x 6x to the fourth divided by 4 plus 6x to the third divided by 3 plus 40x squared divided by 2 plus 25x. And I'm going to evaluate that from 1 to 4. This can be simplified down a little bit. Okay, so I just simplified down, for example, the 8x to the fourth over 4. Again, you may want to pause and make sure that you can get that simplified, because our last step then is to evaluate. So what we're going to do is evaluate that at 4 and evaluate at 1, and we're going to subtract those two answers. And make sure you don't drop your pi. That's part of the volume. So I just substitute 4 into the equation. And again, you'll want to calculate this out on your own, but that gives us 240.8 pi would be our f of 4. And now let's evaluate that at f of 1. So evaluating that by substituting 1 in for x gives me 45.2 pi. We're going to subtract those to get the full volume of our solid. So 240.8 pi minus 45.2 pi gives us a final volume of 195.6 pi.